Cosmologists all across the globe have been very excited this past March due to the release of the data from the Planck satellite. This experiment was important enough that it even made the front page of the New York Times. So, what is all of this excitement about? The Planck satellite made measurements of the cosmic microwave background radiation, otherwise known as CMB. And if you follow us on this channel, you might have noticed that several times in the past we did talk about the CMB and was important for explanations of anything from dark matter, dark energy, and the Big Bang. So in this video, we will talk in detail about what the CMB is. What exactly is the cosmic microwave background? It turns out that the CMB is the radiation emitted when the universe stopped being a plasma and turned into a gas. So, let's understand now what a plasma is. Let me remind you that plasma is ionized gas. So in this picture on the left, you see the soup of very fast-moving protons and electrons. Plasma holds more similarities with gas. For example, as it expands, it cools. But the main difference between a plasma and a gas is that the emission spectrum for plasma is continuous, whether a gas has both emissions and absorption lines due to the orbitals in which the electrons are constrained. Let's ponder this for a moment. The CMB was emitted 300,000 years after the Big Bang. Part of that radiation traveled for 13.5 billion years just to end its magnificent life absorbed in the detector of the Planck satellite. 300,000 years after the Big Bang is the time when the transition from plasma to gas happened. For the very first time, in the very young age of our cosmos, the light filling the plasma was finally free to move across the universe. In fact, before then, the light was trapped inside of the plasma, which is a perfect black body. So as soon as a photon is emitted from a particle, it is readily reabsorbed from another particle in the dense plasma soup. Why do we have a transition from plasma to gas in the first place? The universe has been expanding ever since the Big Bang. You can recall from before that both plasma and gas, as they expand, they will decrease in temperature. In a plasma, a decrease in temperature corresponds to a decrease in average energy for the photons. When this average energy gets below the ionization energy for hydrogen, finally protons and electrons are free to recombine into atoms and form neutral gas. And this is when the universe becomes transparent. We already said that the plasma is a black body. A black body, at any given temperature, has an associated, well-known spectrum. This plot shows several black body spectrum curves for each temperature. The y-axis represents the intensity, the x-axis the wavelength. You see that as we go down in temperature, the wavelength increases. Pay attention to the lowest curve, which is at 3000 Kelvin. That is the radiation that we're expecting from recombination. I bet you're expecting Planck to have detected this spectrum, but you would be wrong. The 3000 Kelvin spectrum peaks at a wavelength of about 1 micron. But both Planck and all of the previous CMB experiments show that the peak of the blackbody spectrum is has 1 millimeter, which corresponds to a blackbody of about 2.7 Kelvin. Now we're finally ready to understand the beautiful color map that came from the Planck satellite and appeared in the New York Times. Every color pixel on this map is a separate Blackbody spectrum measured to incredible precision. And the variations that you see from blue to red are only about 20 microkelvins. As an example, this point in the sky is at 2.72500 Kelvin. This other one is at 2.72502 Kelvin, and so on. Well, wasn't that a journey? The CMB is one of the most difficult concepts in cosmology, but at the same time is crucial. It's very important, and if you like the subject, you should learn it. That is why we're so happy that we've finally gone through it. But if there's something that you haven't understood, please feel free to rewatch the video again, ask us questions in the comment section below, and I hope that you enjoyed our video. See you next time!